I'll start today's video with 3 facts about you that I bet you didn't know. Fact no. 1. Your phone number has exactly 7 prime factors. Fact no. 2. If you were born in February, your birthday has a 78% chance of occurring before or on your wedding day. And fact no. 3. The ratio of women to men at the beach is 0.69. What do these facts have in common? None of them were random. They were all chosen for their ability to surprise you, which makes them anything but random. In this video, we're going to talk about the real meaning of randomness. We'll explore what it means for something to be truly random and why that's important. We'll discuss the so-called randomness crisis threatening the internet, and we'll explain how one day you might be able to use the seemingly random behavior of quantum particles to make money on Wall Street. If that sounds interesting, keep watching. To understand what randomness really means, we need to start by talking about the opposite of randomness: predictability. Predictability is everywhere in the universe. On large scales, the motion of galaxies is predictable. The weather is predictable. Planets orbit stars in a predictable way, and the stock market is, well, just kidding. But on smaller scales, predictability breaks down. Take, for example, the subatomic realm of quantum mechanics. Here, things get weird. Most physicists think that at the smallest possible scales, the behavior of particles is fundamentally unpredictable. Quantum particles like electrons and photons don't follow fixed paths. Instead, they exist in a haze of possibilities until they're measured. That's the famous quote from Heisenberg: "God doesn't play dice." And indeed, when we look at quantum particles, we see evidence of this inherent unpredictability. For example, sometimes an electron will pass through 2 slits at the same time, or it might not. You can never tell. But does this inherent randomness at small scales have any effect on the world around us? To answer that question, let's first clarify what we mean by randomness. Randomness is often used interchangeably with the word uncertainty, but they don't mean the same thing. Let's say you're trying to guess the outcome of a coin flip. If you have no information to go on, your guess is pure chance. In this case, your guess is random, but it's also highly uncertain. There's a 50% chance you're right and a 50% chance you're wrong. Now imagine you see the coin land heads 10 times in a row. Your uncertainty about the outcome of the next flip has gone away. Now you know it's tails because the coin must land on one side or the other. In this case, your guess isn't random, but there's still an element of uncertainty. You can calculate exactly how likely each outcome is based on what happened last time. We call this type of uncertainty statistical uncertainty, because it stems from the fact that we're dealing with a large number of individual parts. So if we want to find randomness, we need to look for things that are both random and uncertain, like guessing the outcome of a rigged coin toss. Now, you're probably thinking that I'm missing something. After all, we observe randomness all around us. Lots of things seem both random and uncertain, like the results of medical trials or the price of Bitcoin. So where's the catch? Well, what we perceive as randomness could be due to our own lack of information. Consider the weather again. We can predict the weather pretty well in the short term. In fact, in some places, meteorologists can accurately forecast whether it'll rain 14 days in advance, up to 90% of the time. But beyond 14 days, our ability to predict the weather breaks down. Does that mean the weather is random? Not necessarily. It just means we don't have enough information to predict it. This is why many scientists are skeptical of so-called randomness crises. The idea that the sources of randomness we rely on are drying up. Random numbers are used everywhere today. Most obviously, they're used in gambling, lotteries, and the pseudo-random shuffling of songs on. But they're also used in a wide range of scientific and technological applications. For example, medical researchers use random number generators to assign patients to different treatment groups. Financial regulators use them to select banks for audits, and computer scientists use them to share large files quickly. In all of these cases, we rely on a type of random number known as a true random number. True random numbers are generated by unpredictable natural processes like radioactive decay. They're the only numbers that satisfy the strict mathematical definition of randomness. Every time they're generated, they have a certain amount of entropy, a measure of disorder, that satisfies the mathematics of true randomness. But some people are worried that because computers are so good at solving math's neat little puzzles, they've been able to generate their own pseudorandom numbers that are indistinguishable from true random numbers. As a result, some worry that if we start using pseudorandom numbers everywhere, we'll run out of true random numbers. Without true random numbers, we won't be able to fairly select trial participants, audit banks, or shuffle music. Pretty scary stuff. But here's the thing, even if we stopped generating pseudorandom numbers today, we wouldn't run out of random numbers. We'd still have plenty of true randomness left over from the steamy breath of an octopus, or the fluttering of a blue whale's heart. At least that's what some scientists say. Others argue that there's a real randomness crisis, that without access to true random numbers, many of the technologies we rely on will grind to a halt. This debate is far from settled. But regardless of who's right, we should take a moment to appreciate the beauty of the randomness around us, even if it's just an illusion. In quantum mechanics, the unpredictable behavior of quantum particles seems to inject genuine randomness into the universe. But here's the strange thing, this randomness doesn't stay small. Take the weather again. When we zoom out, we see that the movement of large-scale air masses is still somewhat predictable. However, thanks to the chaotic nature of quantum mechanics, tiny changes in the air masses, maybe caused by a quantum particle here or there, can add up to large-scale changes in the weather. Meteorologists call this phenomenon the butterfly effect. Small changes can have huge consequences. If we zoom out further, we can see that this happens everywhere. The stock market may be partly driven by investor sentiment, which is partly driven by news stories, which are partly driven by reporters, who are partly driven by breakfast, which is partly driven by wheat, which is partly driven by the weather. A single quantum event on the other side of the world could theoretically influence what you have for breakfast tomorrow. In fact, every time you hear someone talk about the weather, you're participating in a quantum experiment. This means that although quantum particles themselves are too small to directly observe, their supposedly random behavior can affect everything around us. Some scientists think that this randomness could explain many of the complex patterns we see in nature, from the spirals of a seashell to the folds in our DNA. We don't know for sure, but it's an exciting possibility, and it suggests that rather than worrying about running out of randomness, we should celebrate the fact that the randomness of quantum mechanics influences everything around us. Even this video, in fact, came about because of the random behavior of quantum particles. First, a group of researchers proposed a new theory about the origin of life. Then a journal editor randomly selected their paper to be featured in a special issue. Then a press officer emailed the paper to a science journalist, who then wrote an article about it. And finally, YouTube's recommendation algorithm randomly decided to show you the video you're watching right now. Of course, none of this would have happened without you. Thank you for watching and learning with us. And if you want to see more of our videos, please subscribe. Thanks for being part of our story.